Okay, this is for week 2, Tuesday class. So basically last week we talked about how to calculate volatility of a portfolio. And we basically talked about two cases. The first case is this two stock portfolio case. It's a simple case and we have a formula for that. And then the second case is a special case, that is you have an equally weighted portfolio of many stocks. So today we're going to talk about diversification. But before doing that, I like to talk about, or I like to review what we have learned about the special case of equally weighted portfolio of many stocks. Because the results we obtained would be helpful in understanding diversification for today's class. So basically, remember that the basic assumption is we have many stocks and they're equally weighted. For this special case, we know that the variance can be expressed as this, right? So basically, it's a combination of average variance of individual stocks and average covariance between different stocks. And then, more importantly, we talk about several special cases. For the first case, if you have a lot of stocks, then the variance of the portfolio is really determined by the average covariance between different stocks. And then we talk about, for the other special cases, if stocks have the same distribution but they're independent, then the variance of the portfolio is equal to the variance of an individual stock divided by the number of stocks. And for the third case, if stocks returns have the same distribution but the perfect correlated, then in this case, the variance of the portfolio is really the variance of an individual stock. So there's no deviation here, right? So it's just variance of the portfolio equals the variance of an individual stock. Now, I think I somewhat mentioned during the last class, if you compare the third case and the second case, you can see that for the second case, as you include more and more stocks, that is, as you make your portfolio larger and larger, you will get smaller and smaller variance, right? So basically this implies by adding more stocks into your portfolio, you could enjoy this diversification benefit. And for the third case, because all stocks, their returns are perfectly correlated. So even if you add more stocks into the portfolio, your portfolio's risk will not reduce. In this case, you can see that there is no diversification benefit, right? So this comparison, this result, leads to today's discussion of diversification. So let's first start with a very interesting example. Okay, so let's say we have a firm which is called Winnipeg Insurance Corporation. Let's say at Winnipeg, there is a 1% chance that a home will be robbed or it will be damaged by an earthquake. Right? So there are two different events. The first is robbery. The second is earthquake. And each of them will happen with 1% chance. And then let's say there is this insurance firm, Winnipeg Insurance Corporation, right? This firm would want to sell the theft insurance and earthquake insurance. And there are a total of 100,000 homes in Winnipeg. Now let's first do some calculation, right? Because basically we have learned about how to calculate expected So basically we have learned about how to calculate expectation and the standard deviation. So we will start from there. Okay, Now first let's think about the probability distribution. So mathematically, you can see that for theft, right? Let's say, so it happens, right? It happens with a probability of 1%, and it does not happen, right? It does not happen with the probability of, obviously, 99%. Now, let me denote something happens as 1, right? So, if you see 1, then it means theft happens. And, oops, and I will denote the case when the theft does not happen using 0, right? So theft equals 1 means theft happens and the probability is 1%. Theft equals 0 means theft does not happen and the probability is 99%. Similarly for earthquake, right? For earthquake, we could do the same. So 1, it means earthquake happens. 0, it means earthquake does not happen. Now, clearly, earthquake happens, right, with 1% chance. And earthquake does not happen with 99% chance, right? What you can see here is, obviously, theft and earthquake, they have the same probability distribution, right? And we know that based on probability distribution, you could calculate the expectation and standard deviation. So if theft and earthquake, they have the same probability distribution, then they should have the same standard deviation and expectation, right? So let's think about this from the perspective of a individual homeowner, right? So here what we want to do here is the expected claim and the standard deviation of insurance claim. Again, if you look at this probability distribution here, it says theft happens with 1%. This basically says that theft claim, right? Theft claim happens with a 1% chance, and theft claim does not happen with 99% chance. And similarly, earthquake claim happens with 1% chance, and earthquake claim does not happen with 99% chance. Now we could calculate expected claim, right? So expect claim is, I'll just calculate theft claim because theft claim and earthquake claim, they have the same expected claim, right? So the expected theft claim equals, it happens with 1% chance, and it does not happen with 99% chance. So this implies that the expected claim is just 1%. Now the standard deviation of insurance claim is with 1% chance it happens. Remember that to calculate standard deviation, you would start with variance. To calculate the variance, you would calculate the sum of probability times the squared deviation, right? So with 1% chance it happens, and the value is 1 minus the expected value, which is 0.1. And with the other case, that is, if it does not happen, the probability value is 99%, and because it does not happen, we have the value 0 here, minus the expected value squared, right? So this basically gives us 9.95%, right? So for a individual homeowner, right, from this homeowner's perspective, for either type of insurance claims, the expected claim is given by this number, and the standard deviation of the claim is given by this number, right? So importantly, for the homeowner, I am emphasizing we're just thinking about we're just thinking about the standard deviation and expectation of claim from the perspective of a homeowner. This is important. So for the homeowner, the expectation and the standard deviation are the same for both earthquake and theft, right? So that's the result we have got about the insurance claims from the perspective of the homeowner. Now, more importantly, we want to think about the claims from the perspective of the insurance firm. Right? So now we shift our focus to the insurance firm. So from the insurance firm's perspective, right? What is the expected claims and what is the standard deviation of claims? Note that the insurance firm's perspective is different from a single homeowner's perspective. Why? Well, because for a single homeowner, this homeowner only will have one insurance policy, right? For either theft or for earthquake. And for this firm, right? Let's assume all households in Winnipeg would buy the insurance policies. This implies, from this firm's perspective, this firm will have a portfolio of 100,000 insurance policies, right? So essentially, you can see that for this insurance firm, it has to think about the diversification benefit because it has a portfolio of many insurances. Of course, here we are talking about insurances. It's the same case when you have a lot of stocks. We have a lot of stocks, then you have a portfolio of stocks. You will think about diversification. We have a lot of policies, you have a portfolio of insurance policies. So you would still be able to think about diversification. Now, let's first do some calculation here. So let's first calculate the expected theft claim, right? So basically for theft, each year, 1% of all households will file a claim, and 99% will not. So the expected value of theft claim is with 1% chance, not 1% chance, with 1% households, there is this claim. With 99% households, there is no claim. So the expected theft claim is just 1%. Now, let's look at the earthquake. One important difference between theft and earthquake is, if you think about theft, right? It really happens, I would say case by case. That is, if you have a theft in your home, that does not imply there will be a theft in my home. That is, theft happens independently across different firms, right? There's no correlation here. Now think about earthquake, right? If there is earthquake in Winnipeg, basically you can imagine that all households, all houses will be affected by this earthquake. That is, if your house gets destroyed by the earthquake, then very likely my house will be destroyed by the earthquake too, right? So you can see that in the case of earthquake, there is this almost perfect correlation between different households, right? Um, okay, now let's back to the calculation here. So for earthquake, you can see that there is 1% probability. All households will file a claim because with 1% probability, earthquake happens. And with 99% probability, the earthquake does not happen. So now no households will file a claim. And then in this case, you can see that the expected value of the earthquake claim is 1% chance, there is claim, 99% chance, there's no claim. So again, we get this same expected value of 1%. So let me summarize. Basically, you can see here that from the perspective of the insurance firm, selling theft policies and selling earthquake policies yield the same expected theft claim, right? But you can see here that expectation is just one aspect of the issue. We also need to think about the standard deviation, right? Because the insurance has a portfolio of insurances. So the insurance firm wants to understand what are the risks of these two different types of insurance policies, right? So this leads us to do the calculation of standard deviation. Okay. Remember first, the insurance firm has a portfolio of 100,000 insurance policies. So to understand the risk of these two different portfolios, we need to calculate standard deviation. Now let's look at earthquake insurance. The risk of earthquake is the same among different households, right? Now, think about this. The risk of the earthquake is the same among households. What does this mean here? Well, it basically means if you think about the risk of earthquake as a probability distribution, then it means that this probability distribution is the same among all households. And this probability distribution is perfectly correlated across different households, right? What does this imply here? Well, let's again go back to what we have learned in the previous lecture. Oops. Okay, found it. So it says if stock returns have the same distribution and are perfectly correlated, then the variance of the portfolio equals the variance of an individual stock. Of course, here we are talking about stock returns. In the case of insurance policy, we will have the same result. That is, if insurance policies have the same distribution and they're perfectly correlated, then the variance of the portfolio of insurance policies has the same variance of a single insurance policy, right? So, what does this tell you? Well, this will give you this result. So this basically says the portfolio's standard deviation is the same as an individual insurance policy's standard deviation, which is 9.95%. Okay, this is for earthquake insurance. Okay, now let's think about the case of theft insurance. Now, if you compare theft to earthquake, as we have discussed, you would know that the risk of theft is independent across households, right? So let's again go back to what we have learned from the previous class. So we're looking at the second result here. The second result says if stock returns have the same distribution and they're independent, then the variance of the portfolio equals the variance of a single stock divided by number of stocks. If you use this formula to think about insurance policy, then the result you can get is if insurance policies have the same distribution and they're independent, then the variance of the portfolio of insurance policies equals the variance of a insurance policy divided by number of insurances, right? So this is the important part, right? This denominator, that's the important part here. Okay. So in this case, it implies that the standard deviation of the theft claim equals the standard deviation of a individual claim divided by number of insurance policies. And we have 100,000 households. So we should use 9.95% divided by the square root of 100,000. So this gives us 0.03%. Now, let's summarize our finding, right? So basically, we find out if you just examine the expectation and standard deviation of claim from a individual homeowner's perspective, right, you will get the same result. However, if you examine the expectation and the standard deviation from the insurance firm's perspective, you will get a different result because now you're thinking about a portfolio of insurance policies. For the insurance firm, theft claim and earthquake claim have the same expectation. Both are 1%. However, theft claim has a much smaller standard deviation. It's only 0.03% compared with 9.95% for this earthquake insurance. This basically means selling theft insurance is much safer from the perspective of the insurance firm compared with selling earthquake insurance. If you think about insurance premiums, then you can imagine that the insurance firm will want to charge higher premium for earthquake insurance compared with theft claim. Okay, so you get this takeaway here, and I basically have talked about this. That is, earthquake insurance is very risky because, I think I should actually talk about why earthquake insurance is risky, right? So earthquake insurance is risky for the insurance firm because earthquake risks are perfectly correlated among households, right? So even if you have 100,000 insurance policies in your portfolio, there is no diversification, right? And then we find out the portfolio of theft insurance policies has almost zero risk, right? Why? Well, because theft risks are independent. So if you pool together 100,000 theft risks, then diversification becomes very effective. Why do you get this result? Well, it's because it's because this independence means that some people will get robbed and a lot more people won't get it. And you will generally get a smooth pattern that almost every year you will get 1% of households get robbed, get theft, right? So you have this very nice diversification benefit if theft happens independently among households. We will talk more about this diversification because, again, I have not formally talked about diversification yet. And here we're just using this example to give you the basic idea why or how could you get diversification benefit. Okay, now let's formally talk about common risk, independent risk, and diversification. So first, what is a common risk? So basically, common risk refers to risk which is perfectly correlated. So in our Winnipeg insurance firm example, earthquake risk is a common risk for all households, right? Because if it happens, all households will be affected. If it does not happen, all households will not get affected. Okay. The second type of risk is called independent risk. Basically, independent risk is a type of risk that is uncorrelated. So you can see that theft is a independent risk because, again, your house gets robbed does not imply my house will get robbed, right? So there is this independent relationship between different households with respect to theft. Now, what is this diversification? Diversification refers to the averaging out of independent risks in a large portfolio. If you think about this theft claim, it basically means that the theft claim will be quite predictable from the insurance firm's perspective. It basically means that every year, this insurance firm is expecting 1% of It basically means every year, this insurance firm is expecting that 1% of households will get robbed, and 99% will not get robbed. Right? This pattern will basically repeat every year. So the theft claims are very predictable. Okay. Obviously, our goal is to think about diversification benefit of stock portfolios. So, if you think about risks, if you think about different types of risks with respect to securities, you will get the same type of result. That is, you will have common risk, that is, risk that affects all stocks. You will have independent risk, that is, risk that only affect a particular firm or security or stock. Then you will also get this diversification benefit. That is, if you put a lot of stocks into this portfolio, then generally as you add more stocks into your portfolio's risk, your portfolio's standard deviation will be lower. Okay, now let's see this example here. So roulette wheels are typically marked with numbers 1 through 36 plus 0 and 00. Each of these outcomes is equally likely every time the wheel is spun. If you place a bet on any one number and are correct, the payoff is 35 to 1. That is, if you bet 1, you will receive 36 if you win. That is 35 plus your original $1, and nothing if you lose. Suppose you place a $1 bet on your favorite number. What is the casino's expected profit? And the second question is, what is the standard deviation of this profit for a single bet? Suppose 9 million similar bets are placed throughout the casino in a typical month. What is the standard deviation of the casino's average revenues per dollar bet each month? So you can see that this basically is about statistics, right? However, you can see that You're solving this statistic question because it will give you the idea of diversification. Okay? Now let's start from the first problem. What is the casino's expected profit? To calculate expectation, you want to first find out the probability distribution. So let's see what is the probability distribution of the firm's profit, right? So the casino's profit, let's see. So the problem says if you're right, your payoff is 30 versus 1, and nothing if you lose, right? So in this case, you can see that the firm's profit is minus 35 if the gambler wins, and its profit is positive $1 if the gambler loses, right? Now, what's the probability? What's the probability a gambler could win? Well, you're betting one number. However, there are 38 numbers, right? So 1 through 36 plus 0 and 0, 0. So the probability that a gambler wins is 1 divided by 38. And the probability that a gambler loses is 37 divided by 38. So now we could calculate the expectation here, right? So the expected profit of a single bet, expected profit of a single bet is minus 35 times the probability plus 1 times the probability. So let me copy from the lecture note. So it's 0.0526. This basically means that in expectation, the casino is expecting a positive profit, right? Clearly, it's a very small one. It's about 5 cents. The second question says, what is the standard deviation of this profit for a single bet? So we have finished the first one. Now the second one says, what's the standard deviation of profit of a single bet? Again, we have this probability distribution here, so it's pretty easy for us to calculate the standard deviation, right? So it's the square root of variance. And variance is calculated by probability times squared deviation. So minus 35 minus the expected value plus 37 divided by 38. And 1 minus the expected value. So this gives us, let's see, 5.76. Now, if you compare these two numbers, right, 5 cents versus $5, you can see that from the casino's perspective, even the expected value of a single bet is positive. It's actually a risky business because the standard deviation is about 100 times compared with this expected profit. So it is very risky. Now let's think about the third question. Third question says, suppose there are 9 million bets which are placed in this casino, right, in a typical month. So what is the standard deviation, right? So now we're looking at standard deviation of the profit of 9 million bets, right? Here we have to use the result. That is, the 9 million bets, they have the same probability distribution. They have the same distribution, and they're independent, right? This implies the standard deviation of 9 million bets equals the standard deviation of a single bet divided by number of bets, which is 9 million. Right? So this gives us 5.76 divided by square root 9 million, which gives us point 0019. Now, if you compare this number and this number, you can see that if the casino has a lot of customers, and if the customers make a lot of bets, in this case, if there are 9 million bets, you can see that the risk of this expected profit decreases from 9.75 of a single bet to almost zero for 9 million bets, right? What's the implication here? It says that for this casino business, it could enjoy almost risk-free profit if it has a lot of customers. Why? Well, it's because of diversification, right? So if you have a lot of customers, some customer wins, some customer loses. And in expectation, you will get a smooth, almost a constant profit, right? So again, it's the same lesson. That is, if risks are independent, then diversification is very powerful, right? Okay, let's talk about diversification in stock portfolios. So first, let's talk about firm-specific versus systematic risks. If you think about how stock price changes, then you can imagine that stock price are driven by different kinds of news, right? Different kinds of updates. So there are two types of news which could affect stock price. The first is firm-specific. The second is market-wide. I mean, it's very easy to understand, right? If it's firm specific, it basically means this news is just about a individual firm. And if it's a market-wide news, it means that this news affects all stocks, right? And firm-specific news will bring us independent risks. Independent risks is also called firm-specific risk, idiosyncratic risk, unique risk, unsystematic risk, and diversifiable risk. And if there is this market-wide news, this will generate common risk. Common risk is also called systematic risk, undiversifiable risk, market risk. Now let's look at this example, solve it, and understand the difference between systematic risk versus diversifiable risk. Which of the following risks of a stocks are likely to be firm-specific and diversifiable? And which are likely to be systematic risk, right? Which risk will affect the risk premium that investors will demand? We could first skip the second question, right? We could first skip the second question. Let's just focus on the first question. The risk that the founder and CEO retires. Is this firm-specific or systematic? It's firm-specific, right? Because it refers to a single firm's founder and CEO who wants to retire. Okay, so this is firm specific. Now the second one is, the second one says oil price rises. Production costs are higher. This should be systematic risk, right? Because this risk affects all firms in the economy, right? So this one is systematic. Problem C says the risk that a product design is faulty and the product must be recalled. This is firm specific, right? It refers to a specific firm's specific product. Okay, D says the risk that economy slows, reducing demand for the firm's products. Is this firm specific or market-wide news? Well, I can see that it says the economy slows. If the economy slows, it should affect all firms, right? So this one should be systematic. Okay, now we could finally talk about diversification among stock portfolios. So if you combine many stocks into a large portfolio, then you can imagine you could get the benefit of diversification. The intuition is some firms, they will have good news, and some other firms, they will have some bad news. And then this good news and bad news, they will actually cancel out with each other. So the firm's specific risks for each stock will actually average out. So it basically means that the amount of good or bad news overall, right, on the portfolio level will be relatively constant. However, if you think about systematic risk, then even if you pull all firms together, right, each firm will contain one piece of systematic risk. If you combine these firms together, there's no way you could diversify away the systematic risk, right? Because there is no canceling out effect. So to summarize, if you combine a lot of stocks in a portfolio, firm-specific risks can be diversified away because good news and bad news can cancel out. If you combine a lot of stocks into a portfolio, systematic risks cannot be diversified away. Okay, let's see an example here. Let's assume there are only two kinds of firms in the world, right? Let's call the first firm as type S firm. This type of firms will only be affected by systematic risk. And let's see what kind of systematic risk we're talking about. So there is a 50 chance the economy will be good, and S firms will earn a return of 40%. With 50 chance the economy will be weak and return will be minus 20%. And obviously, if you combine all these type S firms into this portfolio, because they only contain systematic risk, then there is no diversification benefit, right? No matter how many S firms you add into your portfolio. Now, the second firm, let's call them as type I firms. They're only affected by firm-specific risk. The returns are equally likely to be 35% or minus 25%. So you can see that because these firms only contain firm-specific risk, then if you hold a portfolio of many stocks, if you hold a portfolio of many type I firms stocks, then you can see that you will get very good diversification benefit. So the risk will be diversified away. Now, clearly, these two types of firms are two extremes, right? Because generally, in reality, actual firms in the market should be affected by both types of risks, right? The market, the systematic risk, and the firm-specific risks. So basically, you can imagine how this will affect your diversification. So in reality, as you add more firms into your portfolio, you can see that firm-specific risks will be diversified away as you add more and more firms into the portfolio. However, even if you add a lot of firms into the portfolio, you still cannot diversify away systematic risk. This result is reflected into the following picture. You can see that we have three kinds of firms here. Type S firm, remember type S firms refer to firms with only systematic risk. And type I firms, that is firms with only firm-specific risks. A typical firm, that is firms with both type of risks. So you can see that if we're only talking about type S firms, as you increase the number of stocks, right, the volatility of your portfolio keeps the same. So there is no diversification benefit. And if you look at type I firm, and you can see that as you increase the number of stocks, the volatility of your portfolio declines very fast and almost approaches zero, right? Almost approaches zero. This tells you that because these firms contain only firm-specific risks, so you could actually diversify away all their firm-specific risks, and in the end, you will get almost a risk-free portfolio. And then a typical firm contains both types, right? So you can see that as you increase the number of stocks, you indeed enjoy this diversification benefit. However, in the end, the portfolio will contain almost only systematic risks. In this case, as you increase the number of stocks, then the level of systematic risk will almost keep the same. So you won't enjoy a lot of diversification benefit, right? Okay, now let's solve this problem of portfolio volatility. So what is the volatility of the average return of 10 type S firms? What is the volatility of the average return of 10 type I firms? So we are thinking about 10 type S firm. So let's first calculate, okay, let's first think about the probability distribution, right? So let's look at just one type S firm. Let's just look at one type S firm's return. So you can see that it's either 40% or minus 20%. Right? So the return would be 40% or minus 20% with equal probability. So what about type S firm? Sorry, what about type I firm? So let's just look at one type I firm's return. So it's either 35% or minus 25% with equal probability. So it's 35% or minus 25% with 50 probability and 50 probability. So now let's look at standard deviation of 1S firm's return. Obviously, first we have to calculate the expected return, right? Expected return is basically 40% times 50% plus minus 20% times 40%. So, okay, let me write down the expected return. So I guess it's 10%. So the expected return here should be 35% times 50% plus minus 25% times 50%. So this, I think it's also 10%. No, it's 5%. So this gives us 5%. Now the standard deviation would be probability times squared deviation plus probability times squared deviation, right? So this gives us oh, I forgot squared root. So this gives us 30%. Now for type I firms, right, so standard deviation of one type I firm's return equals the square root of 50% times squared deviation plus another 50% times squared deviation. So this gives us 30%. However, we have only computed the standard deviation of one firm's return. We have 10 firms, right? So we have to think about diversification. And we know that type S firms has only systematic risk. So there is no diversification benefit. Basically, it means that the portfolio of 10 type S firms should have the same volatility, have a single type S firm. So the standard deviation of 10 S firms of 10 S firms return is 30%, right? Now, what about type I firms? Well, type I firms, they have only a firm-specific risk. And these risks are actually independent, right? We know that if you have independent risks, then we have the following formula. So 10 I firms return is a single firm's is a single firm's standard deviation divided by square root of number of stocks. So this gives us 30% divided by square root of 10, which gives us 9.5, which gives us 9.5%, right? So here you can see that basically this gives you the numerical example that if you have independent risks, by combining these independent risks, then you will have smaller risk, right? Because that's why you get 9.5% volatility in this portfolio of type I firms versus 30% volatility in the portfolio of type S firms. Okay, now let's think about the risk premium and how risk premium is affected or is related to different risks. The first question is, should investors expect to earn a risk premium when investing in type I firms? I guess this question is not very friendly or not so understandable to you guys. So let me rephrase this. So here this question asks about if you're investing in type I firms, should you expect some additional returns, right? Basically, risk premium means additional returns from bearing risk. Well, the answer to this question is no, right? Even if type I firms are risky, investors should not expect to earn additional returns from investing in type I firms. Now, you might wonder why this is the case, right? Well, the reason is because remember what is a type I firm? Type I firm refers to a firm which has only firm-specific risks. This implies that if you are building a portfolio of type I firms, as you include more and more firms into your portfolio, you will always get a lower and lower risk. So when you have added enough type I firms into your portfolio will almost become riskless, right? So in this case, you can imagine that if you're having a riskless portfolio, you're not bearing risks. So you should not ask for additional compensation. You should not ask for additional returns. So there should not be any risk premium, right? So basically, this basically says that the risk premium for diversifiable risk is 0. So as an investor, you should not get compensation for holding firm-specific risks. Here you can see that the lecture note gives you some explanations why this is the case. I think it's fairly intuitive, so you should be able to read these 2 paragraphs yourselves. Okay. Now, what about systematic risk, right? You can see that the reason that investors, they will not get additional returns from holding diversifiable risks is because these risks are diversifiable, right? If you use a portfolio to hold a lot of diversifiable risks, in the end, portfolio is essentially riskless. But you cannot diversify away systematic risk. And if you're risk averse, meaning that you dislike risk, then you will actually demand some compensation for bearing this systematic risk, right? So you will want a risk premium. In a nutshell, the argument is basically like this. If a risk is diversifiable, you can actually eliminate this type of firm-specific risk using a portfolio, right? Using diversification. So you won't ask for compensation. So there is no risk premium for firm-specific risk. But if you're bearing systematic risk, you cannot diversify away this type of risk. So you will ask for compensation. So there is risk premium for systematic risk. Okay, now let's look at this, I would say this second claim. The risk premium of a security is determined by its systematic risk and does not depend on its diversifiable risk. I won't repeat the reasoning here because we have talked about why this is the case. I would just want to mention that standard deviation as a measure of risk. So here that you can see I have marked the comment in red. So standard deviation is a measure of total risk. Let me change my Apple Pencil color. Okay, so it's a measure of total risk. This is important. What is a total risk? Remember that a stock contains two components. It contains systematic risk and diversifiable risk. It means that if standard deviation is a measure of total risk, then standard deviation measures a combination of systematic risk and diversifiable risk. And then we know that as the investor, you will only get compensation for bearing systematic risk. So there should be the relationship, a positive relationship between return and systematic risk. However, there should not be a positive relationship between return and total risk, which implies there shouldn't be any relationship between return and standard deviation. Okay, let me repeat because this point is actually a little bit of complicated, right? And it's very subtle. Okay, let me repeat. So we know that an investor should get compensation for bearing systematic risk, right? So there should be a positive relationship between the return you get versus systematic risk you bear, right? So positive relationship between return and systematic risk. However, standard deviation is a measure of both systematic risk and diversifiable risk. So we should not observe a relationship, a positive relationship between return and standard deviation. Okay, now let's see. Okay, I guess this point now is still a little bit of vague. So let's look at the next section, which talks about historical trade-off between risk and return. And I hope through this historical example, you could get a better understanding how to explain the relationship between risk and return. So first, let's talk about excess return, right? What is the excess return? Excess return is really the difference between the return and the return of T-bills. Remember, T-bill, return for T-bills really gives you this short-term interest rate. So it really gives you the short-term interest rate. Okay, this is weird. Short-term interest rate. So essentially, excess return can be calculated by return minus interest rate. Let's call this interest as I, right? So it's return minus interest rate. So using historical data, we could actually get some results on return volatility and excess return. So let's first look at this 3 months Canadian TBOs. So the average annual return is about 5.56%, and standard deviation is about 3.1%. So excess return should be zero, right? Because you should use you should use 5.56% minus 5.56% to generate your excess return. Long-term bond, right? Long-term bond average return is 7.6. Return volatility is 10.10%. So excess return is 2.04%. So how do you get this? Well, again, it's basically 7.60% minus 2.56%. Now the Canadian stock market, so annual return is 11.37 and volatility is 17.21. So the excess return is about 5.81%. So we could basically we could basically draw out the relationship between return and volatility, right? Return and volatility by using the following graph here. You can see that we could find out we could look at the relationship between return and volatility for these 4 different portfolios. The first one is the TBOs. Second one, long-term bond. This is the US market. This is the Canadian stock market. What you can see here is there is this positive relationship between return and volatility for these 4 portfolios. Remember that all these 4 dots should give you some sort of portfolios. The reason is because if you think about S&P 500, it has 500 stocks, so it is a portfolio, right? If you think about the 3-month Canadian TBOs, then it could have at a certain point of time, it could have multiple different TBOs. So this is a portfolio of short-term debt. Now, let's add individual firms' return and volatility onto this picture. So here you can see that you have a lot of dots here, right? These dots. These smaller dots are individual firms, right? Now, what you could observe here, if you compare these 4 portfolios with these individual firms on the right-hand side, a very obvious result you can get is, well, these individual firms, they have much higher volatility, right? Remember that the horizontal axis gives you the historical volatility, right? That's the first discovery here. To be more specific, right, we could actually ask 4 questions, and we could use what we have learned to answer these 4 questions. So the first question is, how is that S&P 500, a portfolio of the 500 largest stock, is so much less risky than individual stocks, right? So you can see that we get the individual stocks on the right-hand side, and on the left-hand side, we have these portfolios. So this is S&P 500. These are individual stocks. So why S&P 500? This portfolio is much less riskier compared with individual stocks. Oh, this is easy, right? Because let me write it here. Because individual stocks have both. Okay, my Apple Pen is acting weirdly, so let me just tell you the answer. Well, the reason is because individual stocks have both systematic risks and individual risks, right? It contains both kinds of risks. However, when you combine these individual stocks into a portfolio, it becomes this SP 500 portfolio. In this case, you can see that as you add 500 stocks into this portfolio, then this firm-specific risk will be diversified away. So SP 500 contains only systematic risk, right? So basically you can see that's why SP 500 is less risky, because firm-specific risks have been eliminated, have been removed. Now, the second question is, why wouldn't investors demand a higher return from stocks with a higher volatility? So why do we ask a question like this? Because again, if you look at the right-hand side, right, these individual stocks, they have much higher volatility. But in terms of returns, a lot of stocks, they actually have lower returns compared with SP 500, right? This should be obvious, because if you draw a line like this, right, and you can see that all these stocks below this line, they have higher volatility compared with SP 500, and they have lower returns, right? So now we have this question here. Why wouldn't investors demand a higher return from stocks with a higher volatility? Well, we talk about this because for an individual stock, volatility is a measure of total risk. It contains both systematic risk and firm-specific risk. However, an investor should only demand higher return from bearing systematic risk. An investor should not demand a higher return from bearing firm-specific risk. So if volatility is a measure of both type of risks, then we should not observe a positive relationship between return and volatility. So an investor should not demand a higher return from a higher volatility. Instead, investors should only demand a higher return from a higher systematic risk. Now, the third question, is there a positive relationship between volatility and average returns for large portfolios? Well, if you observe this picture, you can see that yes, there is a positive relationship between return and volatility for large portfolios. Now, the question is why? Well, the reason is because if we have a large portfolio, then this large portfolio will almost contain only systematic risk, because individual specific risks have been diversified away. So for a large portfolio, volatility measures systematic risk. And because there is a positive relationship between return and systematic risk, then there should be a positive relationship between return and volatility for large portfolios. Now, the fourth question, is there a positive relationship between volatility and is there a positive relationship between volatility and average return for individual stocks? Well, if you look at this picture here, right, you can see that we cannot observe a positive relationship between return and volatility for an individual stock. the question is why? Why do we get this result? Well, it's obvious, right? Because again, volatility is just a measure of total risk, which means volatility measures both firm-specific risk and systematic risk for a single stock, right? So for an individual stock, we should not observe a positive relationship between return and volatility because again, the fundamental result is we should only observe the positive relationship between return and systematic risk. So for a single stock, volatility is not a correct measure for systematic risk. So we should not observe a positive relationship between volatility and returns for individual stocks. And for large portfolio, right? Because firm-specific risks have been diversified away for large portfolios. So volatility is a correct measure of systematic risk. That's why we should be able to observe a positive relationship between return and volatility for large portfolios. Okay, that's for today's class.